Good morning, good afternoon, good evening, wherever you are, and welcome to the Mirantis Cloud Platform webinar. I am your host, Nick Chase, and I am here with Sean O'Meara. Sean is the field CTO here at Mirantis, and he is going to be taking us through an overview of what MCP actually is, since there have been a lot of questions about that. Sean is an expert at OpenStack. He's been designing enterprise IT solutions for a couple of decades now. He has also been, before he was the CTO, he was our Europe, our EMEA lead, for those of you who know the term, and he was a senior systems architect. Welcome, Sean.
Good morning, Nick. How are you?
Yeah, I'm good. Thank you. Thank you for joining us. And for those who know me or do not know me, I'm the head of content here at Mirantis and a traditional webinar host. So let us just move on for a minute and take care of a little bit of housekeeping. If you are familiar with this interface, you will know this already, but if not, if you look on the right side of your screen, you will see a place that you can submit questions. Please go ahead if anything kind of confuses you or you think of something you want to know during the webinar, please go ahead and enter a question in the interface. We will collect all of those and answer them at the end. And also at the end, we will provide a link where you can download slides, and the video of this presentation will be made available to you. So moving right along, let's take a quick look at the agenda. So today we're going to start out by talking about what is kind of the landscape? What does upstream mean? What is a distro, and how does this matter? What is the private cloud ecosystem? What does private cloud mean? What are the different pieces? And then we're going to, because if you've been to one of our webinars, you know we try and keep them educational. We're going to talk about the different kinds of things that you need to think about when it comes to operations and upgrades and keeping your cloud up and running, preferably before things break. And then, of course, we will go into Q&A. So I'm going to go on and hand it over to Sean. Sean, take it away. Tell us what is this whole business of upstream versus distro?
Thanks, Nick. So one of the big questions we often hear from in the community and from people is, why not just go to the OpenStack website, go to the Git, download it, and do your own installation of OpenStack? And there are a number of reasons why you would want to choose a distro over doing a DIY method of downloading it from the upstream. So the primary difference is the upstream code doesn't have any of the components of the ecosystem around it. There is support comes from the community, so you have no priority when you request help with anything. Whereas typically with distributions, there is some form of 24/7 support available to help you with any issues that you may have. Further to that, the distributions typically have tested models. Companies like Mirantis, with our distribution, we have very, very standardized deployment models that we test and confirm that all the integration and all the interoperability is working correctly. Plus, we can apply that experience from multiple customers and the learnings from multiple customers so that you don't have to go through the learning cycle every single time you install.
Gotcha. So it's not that there's necessarily anything wrong with upstream. It's just that it's simpler and more streamlined. And if you're running a business, you need that certainty.
Absolutely. And it also, if you're going to go and build your own deployment tool sets, if you're going to integrate all the extra components that don't come from OpenStack yourself, you have to maintain the staffing and the people, and you create the technical debt to support all of that. So that's one of the big advantages you gain from using a distribution. The challenge, the flip side to that, is sometimes distributions, you are reliant on what upstream distributors are, features that they are making available. But with the way that the world's changing to more CI/CD delivered tool sets and more integrated tool sets, that gap is getting narrower and narrower. The other thing you get from buying a distribution is you get access to the partner ecosystems from the distributor. Those are typically hardware and software partners that we have tested our deployments and our tool sets against and verified them both from a support perspective, but also so that large enterprises can place reliance on that software and that it will function as expected. And the hardware will function as expected within the environment. Then, excuse me. Then the other big challenge with upstream is the OpenStack components are very, very complex. And you need access to documentation. You need access to verified deployment models. Quite often you need access to professional services. And if you're doing all that work yourself, and again, I come back to the point of technical debt, you have to maintain all that yourself. So by choosing to use a distribution, you can radically reduce the complexity for your environment. So I think that pretty much, from my perspective, covers the differences.
Okay,
we can
so
segue a little bit into.
right. So now, what does that mean for Mirantis in terms of Mirantis Cloud Platform? How does that all translate into this new platform?
So with Mirantis Cloud Platform, we're still distributing OpenStack. We're still providing what we refer to as the MOS packages, which is the central red box up on your displays now. But we're providing you that ecosystem around that. We're providing Drivetrain. Drivetrain is the lifecycle management tool set that we provide that allows us to deploy and manage the OpenStack tool base, tools in your environment going forward. It also allows us to deploy and manage other cloud platforms. So we're no longer just focusing on OpenStack. We will be deploying with OpenStack and Kubernetes. We'll have OpenContrail as an SDN solution and others, as well as Calico for the Kubernetes environment. And then we're able to deploy and manage storage solutions such as Ceph. The point here is that the deployment for MCP is a lot more than just OpenStack. It is the ecosystem around OpenStack to help you support and deploy your cloud platform.
Gotcha.
Then to the right we have.
Go ahead.
To the right we have Stacklight. Sorry, Nick. Go on.
Okay. No. Go ahead. To the right we have Stacklight, which is.
So Stacklight is our visibility solution for your cloud platform. It allows us to gain insight into what is happening within your cloud platforms, gain insight into what your operational status is, and also to provide a lot more information on capacity planning, capacity management, and troubleshooting information. We'll go into a lot more detail about Stacklight a little bit later on.
Okay, so let's go into more detail then about what it is you actually are going to do. Let's go into the meat of the potatoes, the heart of this.
So as I've discussed, MCP is more than just Mirantis OpenStack. Mirantis
And that's where
OpenStack is
people are, and that's where people are kind of, I don't want to say freaking out, but that's where people are going, all right, I don't understand. What is this now? So, yeah.
So traditionally, we provided Mirantis OpenStack, which were the Mirantis hardened OpenStack packages, and I'll touch on that again just now, which was our opinionated deployment of OpenStack and how we believed OpenStack should have been deployed, which was our reference, based on our reference architectures. And a lot of that is still there. We still have those opinionated deployments. We still have a tested set of models for deploying Mirantis OpenStack. But we're also able now to deploy a number of other solutions. For example, VM and bare metal for bare metal workloads. We're able to deploy Kubernetes to support large enterprise containerization solutions. We're able to deploy a number of different software-defined storage mechanisms, primarily Ceph. And then we're able to customize these clouds based on the use case. So every type of cloud has a specific type of use case requirement. everything from NFV to IoT, or whether it's being used as app dev or for media distribution.
So there's a lot going on here, which means there's a lot of moving pieces in terms of keeping this running. I mean, OpenStack itself didn't exactly have a reputation for being easy to operate. So now we've added more on. So how are we keeping this stable?
So OpenStack has two challenges primarily when we start talking about it being easy. It certainly wasn't easy to deploy, not in an effective and scalable way. And the day two operations were very challenging because of the extreme complexity of OpenStack. So what we've done is we've developed Drivetrain. Drivetrain is our lifecycle management toolset. It allows us to take advantage of continuous release, so it's to deploy MCP. So we can do deployment of the cloud environments, handle all that complexity. Those deployments are model-based, so we're deploying based on very specific models. And those models are able to be customized depending on the unique requirements that you have. But most importantly, we're able to modify and update those environments after the fact. So you no longer deploy an environment and have it stuck without being able to modify it. You're able to update both from a perspective of installing new feature sets and new software, as well as patches, upgrades, and because of the direct connection of Drivetrain to our upstream CI solutions, you are rapidly receiving new updates and new feature sets from us.
Aha.
So Drivetrain is deployed on-site and linked back to the Mirantis core CI toolsets.
Okay. So let me just ask you a quick question here. You said a magic word, and I want to make sure that you said what I thought you said. You said the word upgrade, right? Are you talking about actually upgrading? I mean, I think actually there's a whole section on this, so I probably shouldn't hit it too hard now, but just, you did say upgrade, right?
I did say upgrade. Don't steal thunder here. We will discuss upgrades. And
I'm
sorry. No. I think it's very important that we discuss upgrades. One of the biggest challenges, as we all know, with any complex software solution is managing upgrades and ensuring that customers can place reliance that the environment will continue to run as expected, both during the upgrade process and afterwards. And that brings me to the bottom bullet on the slide, which is the entire point of Drivetrain. The philosophy behind Drivetrain is to ensure that everything is done in an automated, repeatable fashion to help us prevent downtime. Oh, wow. And that is critical to the full ethos of the system that we're deploying here.
Now, preventing downtime has always been a big goal of Mirantis in terms of hardening and things like that.
Mm-hmm. So one of the things that we do extensively, and any of our customers who've used MOS packages before know this, our MOS distribution are heavily hardened, both from a configuration perspective, but as well as we'll often fix bugs that have not yet been fixed in the upstream OpenStack code, and distribute those early to customers or as soon as possible to customers. As part of that process, we have a very thorough hardening and testing cycle that we go through with all of our software distributions. With the advent of pure CI and CD deployment mechanisms as part of our core product set, we're now able to do that testing a lot faster, a lot more effectively. And whilst we do that testing in our own test clouds, we're also pushing that testing down to your cloud so you can test quickly within your own environments. And it's really critical so that you always know, no matter what changes you've made, that continuous testing is there and you can ensure that that cloud will run as expected.
Excellent, excellent. And when you say upstream first bug fixes, what does that mean?
So due to the complexity of the OpenStack community and of OpenStack itself, quite often bugs are discovered and worked on within the latest current releases of OpenStack itself. And it can take time for those to be accepted within the community and distributed fully within the community. And the challenge with that, of course, is if I have a major, as an example, some of the SSL bugs that have been identified over the last year which affect security, I can't wait for community to accept and argue over that. Sometimes I need a fix now.
Right.
And what we're able to do is we're able to provide you a fix now that solves the problem. And then later on, because of the way we do these deployments through the CI and the CD tool chains, we can then merge those into and bring them in alignment with what is being done in upstream.
Ah, okay. So that's how that works. Okay.
Mm-hmm.
All right. So since we're talking about upstream and ecosystems, let's talk about the private cloud ecosystem. So let's get into a little bit more detail. What is actually involved in this whole private cloud ecosystem?
So sure. I mean, one of the things that we have a number, and in my previous role doing consulting with customers and over the last few years, is deploying a private cloud solution is not just deploying a piece of software and walking away. There is a huge amount of complexity in building a system that is stable, that suits your customers' needs, and ensures that you will be able to maintain it on a long-term basis and grow that cloud and those solutions. So this slide that I've got up now is very complex and it's got quite a lot of blocks on it.
Yes, it makes me want to cry just a little.
Makes me want to cry, and I drew it. This is just showing what I would refer to as the underlay cloud components that need to be taken into account when developing a private cloud solution. It's the combination of networking, operating systems, cloud operating systems, so OpenStack or Kubernetes, overlay networking, plus all the tool sets that I require around that to control this environment and to ensure that I can at all times provide uptime to my customers, that I can provide information to them as to their utilization, that they can ensure that they can understand if a workload isn't performing correctly, what the impact of that is, and how to determine where they're having challenges. I mean, the big one for a lot of people is things like billing, KPIs. How do I know that I'm performing the way I'm meant to be performing? How do I handle change management? How do I handle incident management? How do I deal with this hugely complex environment that I am creating, yet make it easy to operate? So these are just some of the components we have to take into account. We are trying to solve a lot of these problems through the CI/CD and through our understanding of the enterprise. And these are just a few of the challenges you have to deal with when building out a private cloud.
So then what part of this is actually OpenStack?
The little red box on the right-hand side, bottom right-hand side.
And I think that little box is like 10% of the... Okay.
Yeah, that little 10%, let me flick back there. And that's the reality. People seem to think of OpenStack as this massive thing that sits on its own. OpenStack is rather useless on its own. It still needs a number of other components to make it an effective system. So this brings me to a little point which I like to make, and it sometimes makes me unpopular, but we have to realize that OpenStack itself is essentially just an abstraction layer. It provides a common set of APIs that allows us to address infrastructure resources.
It's a very good abstraction layer, but it is an abstraction layer.
And it's a fantastic abstraction layer, and I'm not knocking OpenStack here. What I'm trying to say is it on its own doesn't do very much. It has to be paired with a huge number of other components to make it an effective solution.
Okay.
Those components, well, we need a message queue. We need hardware. We need virtualization software. We need databases. And just to give you an example of the number of systems and components that are included in MCP, these are the open source components and tool chains that we have included with MCP and integrated.
That's a
If
lot.
we go, it is a huge number, and it's growing all the time as customers identify extra needs, as new feature sets and requirements come in. Now, if we just have a look at some of the core components here, we've got OpenStack and Kubernetes, which is still at the heart of what we're providing. But then we need to look at the various operating systems. All these applications and tool sets have to run somewhere. We've got the hardware management. We've got things like OpenContrail for SDNs. We've got Calico on the top right. We've got OVS, which is related to all of this, which is a separate component. And it goes on and on. There are core components that we require, like Rabbit for message queuing, MySQL for the database, for maintaining the state of the environment. But for many of you, you'll recognize a number of these tool sets and have probably dealt with them in some way or form before, mostly when they go wrong. What I think the point is, there are a couple of core components that are enabling us here, and that is Jenkins, Gerrit. Those two combined with the salt stack components are what are becoming core to MCP. They allow us to handle this complexity and deal with it in a controlled fashion.
Yeah, if I thought the other diagram wanted to make me cry, this one really wants to make me cry.
You should see this later with all the interactions. There's a lovely interactions diagram that we have, which is basically on this format would just be a black block on the screen.
No!
I'm afraid so.
So how do you manage all this?
So that leads us into what I was talking about with regards to Jenkins, SaltStack, Gerrit. This is essentially Drivetrain. Drivetrain is a combination, once again, of open source tool sets, specifically Gerrit, Git, Jenkins, SaltStack, and Artifactory. What this allows us to do is it allows us to treat our environment as code. It's the buzzword at the moment, infrastructure as code, and it provides the controls as well as for both software and configuration through a set of pipelines that ensures that anything we deploy to the environment can go through a proper set of tests. We can control who is making changes through Gerrit and Gerrit workflows. All the information about our environment, the source code, both for the software source code as well as the configuration source code, is all stored in Git and controlled through Git and versioned primarily, which is a critical component for reporting on change management. And then we're utilizing SaltStack to do the push to actually make those changes.
And for those of you who are not familiar, Salt is a configuration management like, you know, Puppet or Ansible or whatever. And we did do a, I'm sorry to interrupt you, but we did do a whole webinar on Salt. So if you kind of need a refresher on what is that and how does that work, you go ahead and click the link in that when we give you the slides, which you'll get when this is over, and then you can refresh yourself on Salt. Sorry, go ahead.
It's well worth the time. I actually went through it recently just to get an understanding of what we presented, and it's a great presentation. Very, very much well worth the time.
Cool. Thank you. All right.
But so coming back to the point here, Drivetrain is essentially gives us control. It's about controlling the environment in such a way that we always are able to roll back changes should we need to, but we can also roll forward changes. And we can make small iterative changes rather than large big bang changes over time.
All right. So let's see what that means for moving forward. So what does that mean in terms of operations? You know, I mean, you've got a lot, there's a lot involved in just operating a cloud. You've got it installed, now what?
So we've talked on talked around the point that it's not just an installation. We have to look after these clouds once we've installed them. We have to deal with a large number of different moving parts. And typically, most clouds have a small number of very demanding requirements from their consumers. And those are, we need to deal with multiple different types of workloads, whether they are VMs, container-based, bare metal. Each of those have a number of very complex interactions that they have. And so what we require is we require hassle-free operation. We don't want to be stressing about whether these environments are up and running. We want to ensure that we have resilience at scale. And we want to be able to move forward with these clouds and rapidly gain access to new innovations. So moving along.
Okay.
So
what does that mean? Yeah.
We need to achieve this are a large number of things, and I've touched on some of these. One of the critical points is we need to understand our staffing. We need to understand the controls required to operate these clouds. We need systems to control them, such as CI/CD. We need to have a good insight into the workload. What type of workloads we're running and why are they running? And are they suitable for cloud? Not every workload is. We need to understand our supportability.
Okay. Supportability.
We need to be able to report on the status of the environment. Is it all running and running as expected? If there are issues, where are those issues and what is the impact of those issues? We need to be able to update these environments. We need to be able to align our roadmaps, which is related to updates. But we need to understand, I'm going to need these new features for this new customer in 6 months' time. How do I get there? How much customization do I have to achieve? And finally, all of this is based on community. We have to understand that most of these cloud platforms are community-driven. How do we feed back into the community? How do we handle the change in community? How do we ensure that these clouds are going to be operating the way we expect them and that the features we require will still be there in 6 months' time?
Aha, okay. So we're not just doing all this and keeping it internally.
Absolutely not. We're applying all of our learnings from deploying many clouds of many different customers back into our tool set on an ongoing basis. And the beauty of this is we've now moved from a deployment-centric model where we focused on just deploying OpenStack to what we refer to as an ops-centric model. We're going from fire and forget deployments where if you wanted something new, you had to redeploy, to continuous deployment with the idea that we can constantly have insights into our environment, that the platform can be extended as necessary. We have a good capability to upgrade, update, and change configuration on the platform as fast as possible. Big requirement for enterprises is we need to be able to handle change. We need to not only know that we can make change, but we need to be able to control change and report on it. We're also, a big point of what we're doing is instead of having tightly integrated components within the system, we're focusing on flexible and open integrations, which we refer to as loosely integrated. This allows us to pull out and change parts as and when better components become available, or when changing requirements require that we use different components. And I touched on this previously. One of the big components which we need to handle is incremental change. We don't want to be making big, large, complex changes to the environment. We want to be able to make small, iterative changes that add up to the big whole. That way we can identify issues or problems rapidly, deal with them, and either roll forward or roll back as necessary.
Right. So you can make a change, and then if it doesn't work, you can roll it back and get rid of it.
Absolutely, yeah. And that's critical to the management of any complex environment. Sometimes things are done based on, let's experiment. Not always, but it does happen.
Right. Okay. Well, you know, it's a new, we're in a new field, really. So a lot of what we do is experimental when you come right down to it.
Absolutely. And every environment has slightly different needs. And we need to be able to modify things to suit those needs. And those small changes allow us to do that whilst being able to identify the impact.
Okay. So now you said the magic word again, upgrade.
Yes, it does seem to, yeah, doesn't it?
I'm going to put you on the spot on it now.
Rearing its ugly head again, yes. So let's talk a little bit about upgrade. Most of us have pulled our hair out at some point in our lives over some piece of software updating, generally when it goes horribly wrong, which seems to be always when there's an upgrade. So let's have a look at how we're handling upgrades. We have separated, and I've spoken about the separation of the cloud into loosely integrated components. And this is critical to our ability to upgrade and update the various environments. So we have what we would consider core services and support services. And we have separated them from an upgrade perspective. You no longer are tied to upgrading, for example, drivetrain to upgrade OpenStack. You can do them individually. Each service component, as part of the core services, can also be upgraded individually insofar as all the support capability is there. There's no need to tightly integrate all the upgrade components anymore. Mm-hmm. This is handled through drivetrain, and again, it is handled through these small iterative changes as and when necessary.
Right. Okay. So go ahead. Sorry, didn't mean to interrupt you.
No, sorry. So MCP, we had a number of objectives when we designed the processes that we would use to do upgrades. We need to understand, and we've spoken about this, MCP is not just OpenStack anymore. OpenStack is a component of MCP. And we showed that box in the bottom right-hand corner that was OpenStack, and it's becoming less and less of the whole of MCP.
Not because OpenStack itself is shrinking, but because there's more and more coming in.
But what is changing is that we're providing more and more of the ecosystem components around OpenStack. We're still focused on OpenStack, and OpenStack is still key to what we do. But we're now focusing more on how do you operate OpenStack? How do you operate your private cloud? And how do I upgrade and manage that into the future? And this is where the questions start to get asked. With regards to upgrades, rather than just blanket upgrading because I have to achieve a new feature, what is the business value in an upgrade? What do I need to upgrade just to achieve my goal? Whether that goal is a stable system or whether that goal is a new feature set or a security patch. What is my business value? The beauty of this is I can now choose to upgrade just the components that impact my business requirement rather than having to deal with the complexity of upgrading the whole to do one small change. So,
okay.
There's this old adage, if you don't touch a running system because of its complexity, the chance that you may take it down, we don't have to have that problem anymore. We can touch the running system and we can make changes without any impact. Well, with understanding of the impact, I think is a better way to put it.
Well, now, why is it important that you can't just leave a running system up forever? I mean, or can you? I mean, there is still at least one OpenStack installation running Essex right now. I mean, we're not laughing at them. I mean, God bless them. I mean, it must be a really stable system if it's still up and, at this point. But I mean, what's wrong with just leaving, if it ain't broke, don't fix it. What's wrong with that?
The biggest challenge with that is technical debt. You're creating a lot of debt for your environment, for your customer, for yourself. You are putting yourself in a risky situation where potential security problems have not been identified in that older software and still have huge gaping holes. Plus, you start to get erosion of understanding of what the system is capable of. People don't use the system as effectively because there's nobody around who understands it. No one has the depth of knowledge. So people start to see the system as archaic and unusable. And therefore, somebody comes along and says, let's do a big bang upgrade, or let's rip and replace this old solution with something new and spend a lot of money on that, which is unnecessary most of the time.
Or even this hardware has died, we need to replace it, but the drivers that it counts on don't work on the new hardware that you're putting in.
Yep, absolutely. That's a very good point.
So, all right. So what is the difference between an upgrade and just, say, an update?
So with regards to updates, I've spoken quite a lot about smaller iterative changes to an environment, and that's really what an update is. It allows us to do small changes, minor component releases, maybe just to fix a small bug, generally not a huge feature change, just to deal with small changes, bug fixes, maintenance releases, security patching. That falls into the update box.
Okay.
Upgrades, typically where we start talking about major feature enhancements, where a customer is demanding new features, or new features are being made available in the industry that people want to take advantage of. That's where we start talking upgrades. It's when the fundamental functionality of the system is going to change. That is an upgrade. Updates typically can be done with very little impact, very low change control requirement, and are unlikely to affect the way people consume the cloud. Upgrades, on the other hand, will typically have quite a large impact on the way people expect to consume the cloud, and will need more work with, not so much as a technical level always, but at a consumer level to make them understand how that's going to change.
Okay. So now how does it work in MCP? I mean, how do these different types of changes work?
So within MCP, every change is handled through a set of pipelines. So if we're talking about updating of packages, which is typically smaller changes, we're able to handle the pipeline where we can, through the pipeline, we can handle the package updates. So for example, if we were upgrading the Nova APIs, we're able to deploy a new set of Nova APIs, verify that they're working, and switch them through the update pipeline. The other option here is, of course, if you just need to make a configuration change. We're able to make that configuration change by picking a specific type of role or state within the environment. We can trigger a test so that we can understand exactly what changes are going to be made to the environment. We can then confirm that change needs to be made. We can make that change in a much smaller subset of the environment, where again we can run the tests, verify now which will be functionality versus just what is being changed. And then finally we can run those changes throughout the rest of the infrastructure with full confidence that they're going to work.
Which is always
this is all handled. Yes, then this is all handled through Jenkins pipelines.
Okay. So in terms of making sure that things are going to work, let's talk a little bit about being proactive with your operations.
Sure. So everybody who's running any large complex solution realizes that to ensure that that solution is going to continue running long term, we need to be able to address potential problems rather than actual problems. And the more proactive we can become, the less we're likely to be running around at 2 a.m. right, dealing with issues, because we can pre-identify them. But I, for one, do like to do it. So to achieve proactive management within any environment, there are a couple of things we need to have. We need to have visibility. We need to be collecting enough data on the environment to ensure that we can identify problems when they occur and that we can identify where there are changes. We need to be able to cover all systems. Within a complex environment, I need to be able to do root cause analysis across the full stack. So everything from my piece of hardware sitting in the data center to the switches, to the software deployments, and I need to understand how all of that is connected and integrated. Once I have all of this data, I need to put it somewhere and I need to be able to analyze it. And the analysis of data is, especially large data sets, is complex. With modern big data analysis, though, it is made a lot easier. And it allows us to compare baselines. It allows us to understand median change in our environment. Then we also have to put controls in place. Without having controls, it's impossible to manage your environment. If everybody can come in and just make a change as they see fit at any point in the day or night, and there is no ownership of that change, then chances are your environment will fall apart pretty quickly, especially if I can't tell you where that change has come from. So we have to put the general controls in place.
Right.
We need to have structures and policies, and we need to understand what our release management processes are, whether for small or large changes. And the more automated those are, the better.
Okay.
And then finally, from a proactive perspective, education is critical for everybody involved. People need to constantly update their knowledge on what the systems are capable of, as well as how to handle them going forward. Plus, the more you drill, the more you review the environment, the more likely you are to find issues and be able to deal with them as quickly as possible.
Okay. So that sounds reasonable. So now what does this have to do with Stacklight?
So Stacklight is the tool set that we've put together. Again, it is based on a large number of open source products, which allows us to collect all this information. The collection and analysis of this information and the presentation of this information is what allows us to, at the end of the day, identify where we're having problems, but also to predict where we may have problems in the future through fault detection, root cause analysis, through understanding the impact that different performance issues are having across the environment. For example, a slowdown in a VM might not be caused by the virtual machine host. It could be access storage or an SDN problem or a time sync issue. So it allows us to get that visibility. It also allows us to look at the environment, and clouds are complex environments and very difficult to do capacity planning on because of their more transient nature of the workloads. So it allows us to identify trends within capacity. We can say that at the end of every month, we suddenly get an extra 1,000 virtual machines, and then they die back at the middle of the month. So we can start doing proper planning. We can tell developers, well, during the middle of the month, you can use as much workload as you want, but at the end of every month, you have to shut down your workload. And then the governance component, which I've touched on, allows us to understand the value I'm getting out of my cloud, understand my cost, the cost versus utilization. And if I have a 1,000-node cloud, but I'm only ever using 200 nodes worth of capacity, what's the point? I may as well get rid of 600 to 800 nodes. Or I need to identify why I'm using that full capacity.
Got it. Okay, and so so the pieces of Stacklight, I shouldn't say the pieces, I mean the things that Stacklight does within MCP, I mean its monitoring consists of ...
So Stacklight for MCP consists of a number of different components. The logging, those of you who have dealt with OpenStack logs realize that Python logs are typically multi-line logs, where the little bit of information you need to identify the problem is buried somewhere in line 22 of the log output of that particular. Again, we're generating sometimes tens of thousands of lines of logs per instance, per node, and all of that information needs to be correlated across hundreds of compute nodes, controller components, and various other subsystems that are required. So we collect all of this information, we push it into Elasticsearch, we then utilize Elasticsearch to do some analysis against the log information, and we're then able to provide insight into the correlation between various components of the logging. Then,
Okay.
so log analysis is one of the most complex things to do in any large environment. We're trying to simplify that by providing standardized, intelligent output that allows you to, at a glance, see what is going on within your environment, but also utilize the knowledge and the learning that we've had from a number of different customers to create standard profiles for you to utilize. Then metering. This is much more traditional. This is service availability metering and resource usage. We're collecting a large amount of information from all the components in the system to determine uptime, to determine I/O capacity, to determine IOPS. And right now we have over 700 checks that we're collecting on, and that's growing daily. And these are standardized and based on our knowledge of OpenStack environments. And as we deploy new environments, new information is pushed back into the Stacklight team and into the product so that customers can gain access to that insight on an ongoing basis. And then finally, it's all good and well collecting this information, but if we don't have a way to alert you when there are problems, it's rather useless because you have to have a body sitting there watching at all times, and that's not great. So we've developed a long list of potential alarms and fault detection scenarios that you can then set up integrated alerting on back to your central operations team. Okay.
Okay. Sounds good. So let's put it all together now. So we've talked about drivetrain and the core and Stacklight. Now let's put it all together.
So putting it all back together, if we go back to this original slide that we showed earlier on, drivetrain controls and deploys this environment. It allows us to manage the environment post-deployment. It provides for our lifecycle management. It provides for upgrades, updates. It provides the control platform, and it provides for change management. Stacklight provides us with the detailed insight into our environment. It provides us with all the operational information we require. It provides us with billing details so we understand who's using our cloud and why, and what we can potentially charge them for. And then
and by we, you mean the customer. You don't mean us, Mirantis.
By me, I mean the customer, yes. Sorry. That's a very fair point. So you, the customer, are able to have that insight into your environment, and you're able to determine the cost value benefit of what you're providing to your customer base, as well as provide your customer base with information as to how they're utilizing the environment, how they can optimize or gain better performance, or manage their costs.
Right.
And then finally, the big central component of MCP, whilst it is still OpenStack, we're able to now start deploying other cloud platform bases. So Kubernetes is a good example. And whatever other potential future cloud platforms you may require, you can deploy them through the single solution of drivetrain and monitor it through Stacklight, regardless of what that particular solution is. And that then ties us all together. The other big point which I want to make here, and that's related to the blocks on the top of the screen, NFV, IoT, AppDev, media, and the list goes on. We're also providing these opinionated reference architectures and deployment models and design models for solutions that meet those particular needs. And that list is growing all the time.
Okay, that sounds terrific. So that's so the next slide actually answers a question that a couple of people have had, which is basically, all right, how is this provided? I mean, it's been phrased a couple of ways, like how come I can't download it, and what does this actually mean in terms of, all right, if I wanted to quote get MCP, how would I do that? And I don't
right now
contact us,
Contact us, yeah. Please. No, there are two primary ways to consume MCP. You can consume it through Mirantis Managed OpenStack, where Mirantis will come in, deploy MCP for you within your environment, and actually take over the operational management of that service for you, guaranteeing high SLAs, performing the proactive monitoring, performing the ongoing and constant support and updates. We joke about things like the Microsoft Patch Tuesday. Well, there's no more Patch Tuesday. Patches can now be pushed by the MMO team as and when they are available, allowing you to far more rapidly deal with any potential risk to your environment.
And that no wait, let me just ask let me just ask one question, because I want to make this clear. That doesn't mean that Mirantis is going to be pushing patches without your permission or knowledge or anything like that, right?
There is a very controlled set of agreed upon change types that we allow as part of MMO. We pre-agree with customers what are considered pre-approved changes. There is still a clear communication process for that. So you'll be pre-informed and you'll have the ability to say no if you need to for changes that will have no impact on your uptime of your environment.
Right.
And then changes that there is a clear change control process that can be integrated to your organization's change control mechanisms to allow us. The proactive component of MMO, though, quite often will pick up issues with your environment long before you know about them. And this is where we bring in skilled people who have knowledge across multiple different platforms and different customers, and who might pick up an issue at one customer and you immediately gain the advantage of that because they're able to fix it in your environment before it affects you. So that is the one delivery mechanism for Mirantis for MCP. The other way of getting MCP is we're able to sell you an on-prem, self-deployed Mirantis Cloud Platform solution, which is all the same software we would install with MMO, but instead of operations, you get 24/7 or 8x5 support. But with the expectation that you're doing your own operations. So as part of your licensing for the platform, you'll gain access to all the software components and all the integration and the support. We would typically recommend that, at least for the initial install, that you do it via our professional services, but that's not entirely necessary.
It's not required. It's recommended.
Not required. It's recommended, but not required.
If you remember all of those slides that made us want to cry, it's really recommended. Okay.
It really just helps you far more rapidly get into a situation where you have a running cloud.
Right. So, okay, so let us, so is there anything else you want to add before we move on to questions? Because we only have a few minutes left.
Yeah.
Anything else you want to address?
No, I think that pretty much covers it. I think what I want to just comment is that we are still pure play when it comes to OpenStack. We're still very involved in the OpenStack community. Our biggest goal, though, is to start focusing on more day two operations capabilities within the cloud environment, and we're ensuring that customers can run clouds with as much ease as possible and scale those clouds as quickly and as rapidly as possible. And that is now a big part of our focus here.
All right. So let's move on to the thank yous, and let's see if we can't get in a couple of rapid fire questions. So one sentence. Why does MCP have two different SDNs?
So we've got two SDNs. We can actually support more. Primarily, we've got the underlay or the overlay SDN for virtualization traffic, which is for virtual machines. And we've implemented Calico SDN only for Kubernetes.
Okay. Can MOS environments be upgraded to MCP?
Not directly. It's going to have to be done through a services engagement at the moment.
But it can be done.
It can be done. There is a certain level of complexity, and it's unlikely that we'll do it with anything other than MOS 9.
Got it. Oh,
although it is possible to do through the versions, it just creates a level of complexity.
Got it. So MCP is a bundle of pieces with OpenStack and Kubernetes working together for OpenStack and container platforms, or OpenStack is deployed on Kubernetes?
Both.
Did you say both?
So both.
Okay.
MCP is deployed both on Kubernetes as well as, and this will be MCP 1.1, but MCP is deployed both on Kubernetes and it deploys Kubernetes.
Okay. Is there a specific version of Open Contrail and Kubernetes, or will it be continuously integrated by the CI/CD chain more or less live from upstream?
It will be continually integrated. There will obviously be known good versions as part of the deployment. So any time that a new version is rolled out, there will be known goods. There are integration challenges sometimes with Open Contrail. There are certain versions of both OpenStack and Contrail that need to work together due to the APIs.
All right.
But that'll be handled through known good. But other than that, it will be continuously integrated.
Okay. Is Drivetrain free?
No.
Okay.
Drivetrain is part of the support licensing.
Got it.
It's part of our product.
All right. Now, is it only for MCP, or can it be used with MOS?
Drivetrain deploys MOS, so it is only for MCP, but its job is to deploy MOS.
Okay. So is it replacing Fuel? Drivetrain.
It is replacing Fuel.
Okay.
Correct.
So all right. So we're moving away from the Fuel-based deployment. We're not, like, quote unquote ditching Fuel, as one person asked, but we're moving towards Drivetrain instead.
And I think it's important just to note that we will continue to support Fuel.
Okay.
We just won't be making major changes to Fuel going forward. So any customer who's still running a Fuel environment, your support will still be there, and your account team will be reaching out to you over the next few months to discuss with you the process of moving you to MCP.
Okay. We have a ton of questions that we didn't get to, and I'm going to try and get them out in a blog post to get them answered, because we are now at the end of our time. But I wanted to thank Sean O'Meara and John Janschig and Michelle Yakura for helping us with our support. And I want to thank all of you for coming out and spending your time. I know everyone's busy, and it's difficult to allocate the time. So we really appreciate all of you spending the time with us, and we will try and get you the answers to your questions. And thank you all for joining us, and we'll see you next time.
Thank you, everybody.
Okay, thank you. Okay, thank you.